This lesson is teaching us how to compare slopes of lines to determine if they're parallel, perpendicular, or neither. So let's first talk about just what parallel slopes mean. Parallel slopes are slopes that are the same. So if we have same slopes, that means that our change in y over change in x is the same. For example, 3/4. If I want a slope that's parallel to 3/4, it would just be the same slope, 3/4. Perpendicular slopes are opposite reciprocals. Opposite reciprocals kind of have two meanings. The term opposite means that it changes sign. The term reciprocal means that the fraction flips. In order for something to be perpendicular, both of those things have to happen. So for example, if we take our 3/4, to make the slope perpendicular, the fraction has to flip. So instead of 3/4, it becomes 4/3. Changing the sign, this one is positive, so this one would be negative. Another example could be -2. To make that perpendicular, a lot of our minds automatically think of just 2, opposite. But we forget that this -2 is technically over a 1. And when we flip that fraction, 1 moves up to the top. The 2 does change from negative to positive, but it's not just a positive 2 because that 1 was on the bottom. So let's try number 1. On number 1, we're going to calculate whether or not the slopes are parallel, perpendicular, or neither. What you're going to do is find the slopes of each set and then compare. I'm going to label x1, y1, x2, y2. I'm going to go ahead and do that over here as well. That way we have everything kind of organized so we can start. The slope formula, again, in case we've forgotten, is change in y over change in x. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So substituting in, y2 is 6, so 6 minus y1 is 3 over 4 minus 2. You are more than welcome to type this directly into your calculator. Just make sure if you do, you put the top in parentheses and the bottom in parentheses. So we're going to go ahead and do parenthesis 6 minus 3, close parenthesis, divided by 4 minus 2. It would probably help if I closed the parentheses the right way. Let's see here. I'll just retype it. How about that? 6 minus 3 divided by parenthesis 4 minus 2. I get a decimal. We want slope to always be a fraction, so I'm going to press math. Option 1, so enter. Change answer to fraction. Yes, so press enter again and you get 3/2. So your new slope is 3/2. Now, in order for our slopes to be parallel, we need to get 3/2 over here. In order for our slopes to be perpendicular, we would need to get -2/3. And if neither of those work, then the answer is neither. They're not perpendicular or parallel. So let's try. We get y sub 2, so 8 minus 2 over 0 minus -4. Again, typing this directly into your calculator, just make sure that the numerator and denominator are both put into parentheses so we can simplify faster. So parenthesis 8 minus 2, and then divided by 0 minus -4. Again, we get a decimal. 3/2 is our reduced fraction. So what we're going to do now is just compare them. Looking at our slopes, I have a slope of 3/2 and a slope of 3/2. Those slopes are the same, so our answer is parallel. Trying a problem like number 2 where we're not giving points, all we have to do in a problem like this is go ahead and just solve for y. So in y equals mx plus b form, I can already identify the slope. The slope in my problem is 1/3. Not 1/3 x, just 1/3. On the second problem though, my slope is not -3. So what we're going to have to do is isolate the variable of y. So I'm going to move y to the other, or I'm going to keep y here and I'm going to move this x value to the other side through addition. Your negative 3x and your 3x cancel. Bring down your y. And I'm going to go ahead and move my positive 3x to the front and bring over my positive 2. In this problem, our slope is 3. Most of us should remember that we need to make sure the 3 is technically over 1. And at first glance, we're looking at it and we're going to say, oh, those are perpendicular because the fraction flipped. But we're forgetting that the fraction also has to change sign for it to be considered perpendicular. So when we're comparing our slopes with 3 over 1 and comparing it to 1 over 3, the fractions flipped, but the signs did not change. So this is neither parallel or perpendicular. Our next type of problem is writing equations through given points, and this is a very heavily tested subject on the state test, so we're going to spend a little bit of time on it. The pattern doesn't change, and we're going to just kind of talk through some shortcuts. So it says write the equation in slope-intercept form of a line parallel to the line and goes through the point. So we've got y equals 3x plus 6, and the point is 4, 7. The first thing you have to do is make sure that you know what kind of slope you're working with. And in this problem, it clearly says parallel. You cannot ignore the fact that it wants parallel, because in our next problem, it's going to want perpendicular. So the first thing you need to do is make sure that you can identify your parallel slope. Well, this equation is already solved for y, so my slope is 3. If I want a slope to be parallel, that means I'm going to use the exact same slope. So my parallel slope is just 3. That's all you use this equation for, is just to find the slope. Now we have our point, x1 and y1. Here is the part that really confuses us. It says write it in slope-intercept form, so what we want to try to do is put it into y equals mx plus b. However, you can't just jump into writing that equation. If I give you a point and a slope, you have to use point-slope form. That's why I'm giving you the point and the slope. You can always solve point-slope to get to slope-intercept. So that's the part that throws a lot of you off on the state test, is it says slope-intercept, and you want to think, oh, I have to immediately jump to slope-intercept. That's not the case. You actually have to solve to get to it. So I have my point, I have my slope. I have to start at point-slope form. If you don't start at point-slope form, you'll never get to y equals form. So y minus y1 equals m parenthesis x minus x1. I'm going to go ahead and substitute y, and in this problem, my y1 value is 7. So when I plug in y1 here, I actually end up with it looking like a negative 7. Remember, we talked previously that the negative 7, it's going to look negative when it's really a positive. Then I'm going to sub in my slope. Ooh, that is the wrong color. I'm going to sub in my slope of 3. So my m value changes to 3. Parenthesis x minus my x1 value is 4. So I'm going to sub in x1, and it's going to look like this with a 4. Once you put it in this form, all you have to now do is solve for y. You don't have to do anything else. Solve for y. That's how you put it into slope-intercept form. You have to start out with what you have. I have a point, I have a slope. I have to start at point-slope form. That's why it's called point-slope form. From here, all you have to do is distribute. So I'm going to bring down my y minus 7. 3 times x is 3x. 3 times negative 4 is negative 12. Again, our goal here is to solve for y. So I'm going to move the 7 to the other side. Just remember that when you're doing these kinds of problems, you want to make sure that everything lines up correctly. So I'm going to bring this down. I'm going to have y equals 3x. Negative 12 plus 7 is negative 5. This is now in slope-intercept form because we solved for y. The next problem is going to be the exact same type of problem, only now we're going to deal in terms of perpendicular. So it's really important that we're reading our question. So it says, write the equation in slope-intercept form of a line perpendicular to the line and goes through the point. In this problem, again, slope-intercept form, but I'm given a point. I need to start in point slope. But before we do that, we have to pay attention to the fact that we want a perpendicular line. It's going to change. It's not always going to be the same. So I'm going to look at my slope. My slope is -5. I want to make it perpendicular. So remember, there's like an imaginary 1 underneath this. Flip the fraction, change the sign. It was negative, it's now positive. We want to use 1/5 in this problem. This is x1, this is y1. You have to start in point slope form first because you have a point and you have a slope. So y minus -1 is a positive 1. My slope is 1/5, x minus 2. Again, once we get to here, all you have to do is solve for y. That's it. So I'm going to distribute. Y plus 1 equals 1/2 times, or 1/5 times x is 1/5 x minus 2/5. Now, if you're unsure on how to distribute with fractions, this -2 is technically over a 1. So all you have to do is do numerator times numerator. 1 times -2, -2. Denominator times denominator. 5 times 1, 5. Once you get to here, you're still just solving for y, so I'm going to subtract 1 on both sides and get y equals, because these cancel, 1/5 x. And if you're not good with fractions, it's okay. You don't have to be amazing at fractions. All you have to do is just make sure you can type it in your calculator correctly. So parenthesis, -2/5 minus 1 gives us a decimal, math enter, gives us the fraction of 7/5, -7/5. So we're going to put minus 7/5. So the main difference between these two problems is, in the first one, it's parallel, so the slopes have to stay the same. In the second one, it's perpendicular, and you have to change them.